To kick off today's episode, let's break down the basic structure of our planet. Dr. Patel, can you explain how Earth's layers are organized and why that matters to geologists?
Absolutely. Earth is like a giant onion with multiple layers. The crust, mantle, outer core, and inner core. Each layer has unique properties. Think of the crust as a thin eggshell, while the mantle is like a slow-moving, hot taffy. This arrangement influences everything from earthquakes to volcanic activity.
That's fascinating. Some people imagine the mantle as liquid, but isn't it actually more solid, moving slowly over time?
Correct. The mantle is solid rock, but under immense heat and pressure, it flows slowly, similar to how glass can flow very gradually over decades. This movement drives plate tectonics, which we'll get to shortly.
Before we move on, how do we know what's inside Earth if we can't dig that deep?
Great question. Seismology gives us clue. When earthquakes occur, seismic waves travel through Earth, changing speed and direction depending on whether they pass through solid or liquid layers, much like how light bends in water. These patterns reveal Earth's internal structure.
Building on the mantle's movement, let's talk about plate tectonics. Many listeners know plates move, but what drives these colossal shifts?
It's all about convection currents in the mantle. Hot material rises, cools near the crust, and then sinks, creating a conveyor belt effect. This motion drags tectonic plates, giant slabs of Earth's crust causing continents to drift, oceans to widen, and mountains to form.
So, is this why we get earthquakes and volcanoes at plate boundaries?
Exactly. Where plates collide, we see mountain building like the Himalayas. Where they pull apart, new crust forms, such as at the Mid-Atlantic Ridge. At transform boundaries, like California's San Andreas Fault, plates slide past each other, triggering frequent earthquakes.
Are there any regions where the impact of plate tectonics is especially dramatic?
Absolutely. Japan sits at the intersection of several plates, making it prone to powerful quakes and volcanic eruptions. In fact, about 90% of the world's earthquakes occur along the Pacific Ring of Fire, highlighting how plate tectonics shapes our environment.
Let's shift gears to rocks, the building blocks of geology. Could you walk us through the main rock types and how they transform over time?
Certainly. There are three primary rock types. Igneous, formed from cooled magma. Sedimentary, created from compressed layers of minerals and organic material. And metamorphic, which result from existing rocks transformed by heat and pressure. These types are linked in the rock cycle, a continuous process of transformation.
How does this cycle inform our understanding of Earth's history?
Each rock acts like a chapter in Earth's story. Sedimentary rocks can contain fossils, revealing ancient ecosystems. Metamorphic rocks tell us about tectonic pressures. Igneous rocks help us date volcanic eruption. Studying these transitions allows geologists to reconstruct past climates, mass extinctions, and continental movements.
Can you give an example of how the rock cycle plays out in nature?
Sure. Take the Grand Canyon. Its layers showcase over 1 billion years of sedimentary rock, some of which have been uplifted and eroded, exposing igneous and metamorphic rocks below. This visible record illustrates the ongoing dance of geological processes.
As we wrap up, let's discuss practical reasons geology matters. How does it impact our daily lives, beyond academic curiosity?
Geology is central to resource discovery. Think oil, metals, groundwater. It also informs hazard mitigation, predicting landslides, managing earthquake risks, and locating safe sites for infrastructure. For instance, geological surveys influence city planning in quake-prone areas.
That's a great point. With climate change and population growth, are geologists' roles evolving?
Definitely. Geologists now help assess carbon storage sites, analyze soil for agriculture, and even search for rare minerals vital to green technologies. According to the USGS, demand for geological expertise is rising as we seek sustainable solutions.
For listeners curious about the future, what emerging fields in geology excite you most?
Planetary geology is booming. Exploring Mars and the Moon for signs of water or resources is reshaping our understanding of Earth's processes, too. It's an exciting time, with technology unlocking new frontiers both at home and beyond our planet.